All right, my algebra class, let's go to knock these out. We're working on chapter 6 here. I picked these particular problems out to give you a wide range of experience with the different techniques that they've shown you in the lesson. All right, over here it has evaluate the expression. If we do this, I know that the rules say that I have a negative exponent. I'm going to bring it down to the opposite side. I also know that if I have a power to the 0 power, it equals 1. So now this is going to equal, well, it's almost like adding 6 over here, which will make this a 2 to the 0 power over 2 to the 6 power times 1. And as we know, this is going to leave us with 1, because anything to the 0 power is 1. And this would be 2 to the 6 power, which is 64. So I should have 1 over 64. There you go, 1 over 64. All right, 6 is yours to do. Number 7. Now that I know where they're going to reveal, I'm going to work the problem over here. Negative 3 to the negative 3 power. Number 6 to the negative 2 power. I'm going to have to switch this up here because it's a negative 2. I'm going to have to switch this down here because it's a negative 3. This is going to turn this to a negative 6 to the 2nd power over 3 to the 3rd power. 6 to the 2nd power is 36. 3 to the 3rd power is 27. I can divide both of these by 9, and that'll give me 4 over 3. And I can even turn 4 over 3 into 1 1/3. Let me double check my work here. Let's not forget this was a negative, which means this would be a negative, this would be a negative, and so would this. So any one of these answers would be correct. You could have this, you could have this, or you could have this. All of it is correct. Evaluating this expression, let's find out what they came up with. We got negative 4 over 3, which is the second one. They could have simplified it further, but that's fine. 8 is yours to do. I'm going to number 15. Number 15, once again, I'm going to have to shift some exponents around. There's a negative 3 here, so I know that that 4 to the, let me give myself some room again. There we go. That 4 to the, wow, I wanted to write it in pen. Thank you. That 4 to the 3rd power come down here, and the a to the 0 power will remain up there. Of course, a to the 0 power equals 1. That b to the negative 7th power can become b to the 7th power up there. As I said, anything times to the 0 power is times 1, so this is going to remain b to the 7th power. 4 to the 3rd power is 64, because 4 times 4 is 16. 16 times 4 is 64. This should be my answer. B to the 7th over 64. Number 17, let's see, 60 was yours to do. 17, again, I got to shift some of these negatives around. The 2 to the 2nd power is going to stay on the top. That y to the negative 6 power is going to go on the bottom. Because it's going to become a positive 6, right? I guess I should have not even put positive 6. It's already known that it's positive, so it's going to erase that. And then we've got, well, 8 to the 0, or negative 1 power will become 8 to the 1 power. 0 to z to the 0 power, that's going to be times 1. Anything times 0 is 1. X to the negative 7 will come up here, come x to the 7th. Let's see, so all this is going to turn to, well, 2 times 2 is 4, and 4 times 8, well, that's actually 32, and x to the 7th will stay the same. Anything times 1 is itself, so that's y to the 6. I should have 32 x to the 7th over y to the 6. 32x to the 7th over y to the 6. And I'm just going to erase some of that so you can see that's what they came up with for the answer, just like I got. 18 is yours to do. 19, write your answer using only positive exponents. My base is the same, so I'm allowed to go ahead and move my smaller exponent to the other. So this is like saying -2, -2. This is going to give me 5 to the 4th power over 1, because 5 to the 0th power would be 1. 5 to the 4th power, I think it's going to give me 625. I'm going to double check that. I know that 25 times 25, well, we know that 25 is 5 times 5. That's 2 of those 5s. Remember, there's 4 of them, right? And then another 5 times 5 is 25. So this is just 25 times 25. It should give me, let's see, 12, right? And then it's going to be a 50 with a 0. Yep, 625. All right, so yeah, 625 is my answer. Right there. 20 is yours to do, 21. We got a negative w to the 2nd power times a negative w to the 2nd power. Let's work this out carefully. We know that it's going to be a parentheses negative w to the 4th power. Remember, it's got to be, the parentheses got to be around the negative sign as well. If it isn't, not going to work out because it's going to remain negative. But because this exponent's 4, it means we're multiplying a negative sign to itself 4 times. It's going to end up giving us a positive w regardless. So 4, or w to the 4th power, will be our answer. Here we go, w to the 4th power. 22 is yours to do, 23 is mine. We have a power to a power rule here. And that means we're allowed to multiply our exponents. This is simply going to be p to the 24th power. And we're done. All right, 24 is yours to do. And now we have 25. Got 6 to the 10th, negative 10th power over 6 times 6 to the 5th power. Excuse me. Let's see, that's going to give me 6 to the negative 10 plus 5, because remember we're allowed to add our exponents as long as they have the same base. This will give us 6 to the negative 5th power, which means it's really negative 6 over to the negative 5th over 1. That means we have to bring this to the bottom, which turns this to 1 over 6 to the 5th. And unless they multiply it 6 times itself 5 times, this should be my answer. And there we go. 26 is yours to do. Let's do number 27. X to the 5th power over x to the 4th power times x. Now this one over here, I know that I'm going to take this and -4 from this side because it's a smaller exponent, which means I'm -4 from this side. This is going to give me x to the 5 minus 4 over x to the 4 minus 4. And we're multiplying that to x over 1. Well, 4 minus 4, that's 0. Anything to the 0 power is 1. So this is going to be a 1 on the bottom. 5 minus 4 is 1, which we never put 1. Now we got x over 1 times x over 1. And that's just going to give me x to the 2nd power. There we go. 28 yours to do. 31. Describe the correct error by simplifying. If I simplify this, I already wrote down 2 to the 9th, and that's because this was so easy when I was going through it. I was like, oh, you gotta be kidding me. And that's because the rule says if my base is the same, I am allowed to add my exponents, but I do not multiply my base. The only time I'll multiply my base is if my exponents are the same. Okay, so since they're not, this part right here is completely wrong. It should have just been 2 to the 9th power. And that's what we got here, 2 to the 9th power. Okay, not 4 to the 9th power. All right, 32 is yours to do. I've got 49 here. There's a variety of ways to do this following the rules. I'm going to work it out over here, and we'll see what they did over there. They got 3 to the m minus 5, n to the 2nd power, and then 4 to the n power minus 2, the n to the 0 power. Wow. And then they're taking all of this, putting it to the second power, multiplying it to n to the n to the 4th power over 9 to the n power, what a headache, all to the second power. Okay, so remember, let's work at the inside of these first. Remember, we're multiplying. So if I do this, I'm allowed to take the smaller number and move it up. This is going to become a 3 to the m. Let's see. Well, actually, the smaller number is -5, so I'll be moving it down. So this would be -5 plus 5 to get rid of it. And the second power is going to stay up here because it's positive already. And this is going to be 4 to the m. This is -2. And remember, we added 5 over here, so I have to add 5 over here. And then times n to the 0 power. Wow. And again, putting it to the power of 2, multiplying this to, well, we end down here, so we can say that this is to the first power, since it's small one, -1 from both sides. And that's going to put this m to the n, or times n to the 4 minus 1, which is 3. And this is going to be, you know, I should do this step by step. This was 4 minus 1. You know, it's going to be 3. And then this would be 9 down here, because n to the, this would be n to the 0 power, right? And all this is going to get multiplied to the power of 2 again. Wow. So let's work this out. Remember, these are just times 1. So this 5 is going to go away. This is going to be 3 to the n to the second power. I mean, if I wanted to, I could say this was m to the 0 power times n to the second power. And then put 4 times m to the third power, right? Times n to the second power, which we said was times 1. Whew. Multiplying this all to, well, this was m to the n, 4 minus 1 was 3, n to the third power. We said n to the 0 power is 1, so it's 9 times 1. And then we're putting this to the second power. Okay, this is like 3 times 1, because n to the 0 power is 1, times n to the second power. This is still going to be 4 to the m to the third power, and we're going to get rid of the times 1, because anything times 1 is itself. Whew. Now we got over here m to the n to the third power over 9, because 9 times 1 is 9, to the second power. Now remember, the rule is if the exponent is the same, we're allowed to multiply our base. So now I can multiply these bases together. Let's see, well, 3 times 1 is 3, but I also see 3 and 9 here on the bottom. So 3 divided by 3, we're reducing here as 1. 9 divided by 3 is 3. Now I can rewrite this. 1 times 1 is 1, so this is going to be n to the second power over 4 to the m to the third power to the second power times m times n to the third power over 3 to the second power. We still multiply these together now. We got n to the second power times, oh boy, m to the second power over 4m to the third power, all to the second power. Then we've got, we've got 4, we got n times n to the third power divided by 3, all to the second power. Hold on. I've got to get a drink of water. All right, thanks for indulging me there. All right, now we can multiply these across. M doesn't have, well, wait a second, M is down here. Wow, okay, I just seen this. Well, there's an M to the first power down here and an M to the third power down here. So I can literally -1 from this one and -1 here and turn this to n to the second power over 4 times m to the second power, all to the second power, times, let's see here, well, the m is going to disappear here because 4, or m to the 1 minus 1 is 0, right? And anything to the 0 power is 1. So that's going to simply turn this to n to the third power, because anything times 1 is itself, over 3, all to the second power. And now I can say n2 times n3, that's n5, over, well, 4 times 3 is 12. And there's m to the second power all by itself. And all this is now going to be to the second power. This is going to give me 5 times 2, which is n to the 10th power. And 2 times 12, that's, no, 12 times 12, excuse me, that's 144. And m the second times to the second, well, that's 2 times 2, that'd be m to the 4th. I should get n to the 10th power over 144 times m to the 4th power. I hope I'm right. That's an awful lot of area to make a mistake on. Forgive me if I'm wrong. Hey, n to the 10th power over 144 m to the 4th power. It's a miracle. Okay, they look like they went a slightly different route here. They went ahead and took the -2 over here, made it 5 minus 2, which should have gave them, 5 minus 2, which would have gave them a 3 on the bottom still. N to the 2 would have stayed on top. They didn't show the times 1 like I did because they knew anything times 1 is itself. They just crossed it out. Over here, it looks like they left this. For some reason, they took 9 and made it 3 to the second power. I don't know why they did that. I'm going to follow it through to see it to the end. Over here, we have where everything's to the second power, so we can multiply across, right? And is that what they did here? Yeah, it looks like what they did. They took 3 times n to the second power over 4m to the third power to the second power. They distributed the second power to both of them with the fraction to separating them. And over here, n times n to the third power to the second power, and then they took that 3 to the second power to the second power. So that's going to give them, let's see. Oh, then they put the line all the way across because they knew they're multiplying. This is very different. We got n to the second, that should be n to the 4th power. This would be n to the 6th power. 2 times 6 is 6 power, yeah. N to the 4 times n to the 6 to give us 4 plus 6, which is 10. Down here, looks like 3 to the second power, 3 to the 4th power. We're able to subtract 2 from the side, leaving it 3 to the second power, which gives us the 9 we originally had. And then we have m to the 4th power, which remained the same all the way through. And then they had 16 times 9, which gave them 144. Wow. I'm glad that's my last one. You have number 50 to do. I'll see you in class for grading. Have a great night.